Okay, in this video we're looking at the idea of structure, and we're going to look more closely at a material structure. So remember last time we had mentioned this idea that structure can range from, I said crystalline to amorphous, and it can be on a continuum. So imagine that you have a spectrum where at one end is crystalline materials and at the other end is amorphous materials. And you can see in these figures 4.9 and 4.10 on page 73 of Ashby that there are illustrations of different types of crystals. So if we could sort of look into a chunk of metal and see what the atoms looked like while they were inside this metal, we might see at some scale that you would have this long-term arrangement of atoms, and this would be considered a crystalline type of material. You have a what's called long-range order of atoms. And if we, on the other hand, looked at an amorphous material, we might see that the atoms are arranged somewhat randomly. And so in an amorphous material, there is no long-range order. Now, there are examples of amorphous metals, but for the most part, solid metals are considered crystalline. So you can take a liquid metal and cool it so quickly that you create an amorphous structure of the metal, and it has very different properties. If you were looking at other materials, so we consider up here these are metals, and down here amorphous materials essentially are polymers, or polymers are amorphous. Also, glass is amorphous. And at this end we have metals and we have ceramics that are crystalline. Some polymers we might put in this region right here, and we would put partially crystalline polymers. So these types of materials have regions in them that have some an order to them, of the molecules, but then for the most part have more of a random order structure like this.